So in the second chapter of trigonometry, what we're doing is we're using the trig ratios and the methods that we used in the last video to help us find missing sides on right angle triangles. So going forward to using trigonometry on how to find missing sides on right angle triangles. So taken from the last video on the introduction of trigonometry, what we're going to do is we're going to use the trig ratios of tan theta equals opposite over adjacent, sine theta equals opposite over hypotenuse, cos theta equals adjacent over hypotenuse to work out the missing sides of triangles. So before we continue, it's really important that you're able to memorize these formulas, and also equally as important as we're able to label the sides of a triangle. Now again, if you're not too comfortable with this, I'd recommend that you watch the previous video on trigonometry 1 and have a go at the worksheet. So to carry on forward from the last video, there are 4 steps that we need to do when we're trying any particular trig question, particularly when it's related to a right angle triangle. So the first thing we need to do is label the triangle, making sure that we leave whatever is blank blank. The second step is that we pick the correct ratio and write down the formula. Third step is substitute the values into the formula, and then the fourth and final step is solving the equation for x and not forgetting our rounding and units for each of the questions. So let's have a look at some of these questions then. So with regards to the first one, so it says find the length of side x to 1 decimal place. Now the key thing, important thing with this is just stating the obvious, that more often than not, none of these questions will be drawn to scale. So going forward with these then, let's have a look at working through. So what we're going to do is have a go at step 1. So step 1 is we need to label the triangle. So here we've got that theta equals 36 degrees, and all I'm going to do is just write these down. Our hypotenuse, which is the next thing, so h equals 10, and our opposite is going to equal x. Now you'd find that one of these 3 things that you're given is going to be x, or a missing letter. So from this, the next thing we then need to do is think to ourselves, right, which is the formula that uses O and H. Now if I just write down SOHCAHTOA, now you can write down however you remember the formulas. So I'm looking for a trig ratio that uses O and H. So in this case, it's going to be sine. So sine theta equals opposite over hypotenuse. So the second step is just a case of identifying which trig ratio we're going to use and writing down that formula. Now the third step is substituting these numbers. So I'm going to substitute theta equals 36, h equals 10, and opposite equals x into that formula of step 2. So what I've got is I've got sine, and it's going to be 36 is equal to x over 10. So all I've done there is just swap the sort of symbols and letters with the numbers that relate to this particular question. So now step 4, what we now need to do is solve this for x. Now if you think what we're going to try and do is get x by itself, so you think to yourself, well, what's on the same side as x? 10. What's the 10 doing? Dividing. So to get rid of the 10, what we need to do is do the opposite. So what I'm going to do is I'm going to times by 10. So x is going to equal 10 times sine 36. Now you might be asking, well, how do we enter sine 36? Well, if you look on your scientific calculator, you should find a sine button. Now, one thing you want to do is enter the calculation just like we're doing here. Now I'm going to put the 36 in brackets because more modern day calculators now, when you press the sine button, it will automatically open up a bracket because it needs a number to follow it. If there's no number, you come out with a syntax error or a math error on your calculator because it only works when you've got a number in front of it. So now if I type in 10 times sine 36, now before I type that into my calculator, what you want to try and do is make sure that you're not typing sine 36 times 10. Now the reason why we don't want to be doing this is because what the calculator may assume that you're doing is you're doing 36 times 10 before you're using the sine function. So what you want to do is make sure you've got brackets around the 36 and working it this way. Now if I was to type this into my calculator, I would get the same answer. But one thing I would probably recommend that you do is rather than having the times 10 at the end, have it at the front instead, just so that it limits the number of times or the potential of you making a silly mistake. So if I type in 10 times sine 36 into my calculator, I'm going to get an answer of 5.87785, and there's a few other numbers that precede it. Now, in this particular question, it's asked me to round it to one decimal place, so that gives me an answer of 5.9, and it's going to be in centimetres. Now, what's good practice, and how I always usually quote this when I'm teaching, is that to do well in maths, it's about 65% knowledge, 35% common sense. Now, if you think back to the right angle triangle, and particularly the hypotenuse is always the longest side. So when I'm trying to find either the opposite or the adjacent, that answer has always got to be smaller than the hypotenuse. And also, you've got to think to yourself, well, if I was to type in sine 36 times 10, then I would get an answer of 0. And so it's clear to me that I've made a mistake. So always look at the validity of your answer to see, does this look correct? If I end with an answer of 0.00006, then I've definitely gone wrong somewhere, particularly when one of the longest sides is going to be 10 centimetres. So try and have an idea of what looks correct and what doesn't look correct, because it will certainly help identify where silly mistakes have been made. So moving on to another question. So again, we're going to follow through those 4 steps that we highlighted earlier. So question 2. So again, here we've got another triangle, again not drawn to scale. So let's have a look at the first thing we want to do is label the triangle. So here I've got theta is equal to 72 degrees. I've got my hypotenuse, because it's opposite the right angle, so again it's my next point of call, is 14 meters. Now if this is going to be the opposite, as it's opposite the angle opposite theta, then this is going to be A. Now to avoid any confusion, I'm just going to scribble out the O because I don't label any blank sides, or we can just delete it or erase it. So then I've got A equals X. So then from this, what we then want to do is, again using SOHCAHTOA, or however way you remember the trig ratios, you think to yourself, right, which trig ratio uses H and A? Well, that in this case is going to be cos. So the cos formula that I then need to use is cos theta equals the adjacent over the hypotenuse. Now in step 3, all I need to do is substitute these numbers in step 1 into my formula of step 2. So what I end up with is cos 72 equals x over 14. And then for step 4, all I then need to do is get rid of the 14. And how do I do that? Well, I do that by multiplying. So I'm going to type in 14 times cos 72 equals x. Now again, as I've been given the hypotenuse in this particular question, I'm looking for an answer that's going to be smaller than 14. So if I type that all into my calculator, so 14 times cos 72, and the 72 being in brackets, and again, so let me just put that in brackets, so what I'm typing here should be exactly what you've written on your calculator. And if I type that incorrectly, I end up with 4.326237, and there's a few obviously numbers that follow it. Now you might be thinking, well, do I actually need to write the number what's shown on the calculator? Well, it's always good practice for you to do that. It's also easy for you to spot a silly mistake, but obviously it said in the start of this question I need to round the answer up to one decimal place, so it's going to be 4.3 meters in this case to one decimal place, and there is my final answer. So now moving on to example 3, let's just move down to that. So here we've got another triangle here. So again, I'm going to go to the steps of labeling this triangle. So my theta is 45 degrees. Let's just write this as step 1. Now here, this is my H, which is my next step. But again, I'm just going to start by labeling this. So H is going to be that side. This is going to be O, and this is going to be A. But I'm going to get rid of the H because there's no information on H, not even a letter or a number. So all I'm left with is O and A. So again, writing down SOHCAHTOA. So I'm looking for a trig ratio that uses both A and H, and that's going to be tan. So my second step is writing down the formula. So tan theta equals opposite over adjacent. Then step 3, all I then need to do is substitute these numbers in step 1 into my formula of step 2, so I end up with tan 45 equals x over 14.6. So for step 4, all I need to do is take the 14 over 6 over to the other side, so end up with 14.6 times tan 45. Now don't worry too much about the decimal. More complicated questions or high level questions will generally involve decimal numbers, but it's nothing to fear because the method is exactly the same. So again, all I need to do is type in 14.6 times tan 45 into my calculator, and I get an answer of 14.6 centimeters. Now, so looking at this, which kind of makes sense, because now you might be thinking, well, that looks a bit odd because surely that's the same as A. But what we failed to establish at the start of this question is that if this angle here is 45, then this angle here is going to be 45, and therefore means that this is going to be an isosceles triangle. So we didn't need to know it's an isosceles triangle, because obviously what we did is we used the rules of trigonometry to work it out, but that's why it makes sense. So it's always important that when you write down your final answer, think to yourself, hang on a second, does this look a bit odd? Does this look right? And if it doesn't look right, question it, saying, well, what is it about it that makes it look right, doesn't look right? So it's always worth going through there. So as I said, it was a bit sort of odd that we end up with the same 14.6, but when we look at the triangle, because obviously it's not drawn to scale, it doesn't look like an isosceles triangle, but that's where it comes into fruition. So moving on to something else that that might help you in terms of understanding what we need to do. Now, you may have come across in your science the distance, speed, time triangle that's been worked through. Now, if you're not too sure about what I'm talking about, then whenever you're working the speed of something, we tend to use this triangle. Now, when we're using this triangle, depending on what you wanted to work out, that's usually what you cover up, or you put your thumb over it, or your hand over it, or something. So if I wanted to work out the speed, I cover my S, and I know that it's distance divided by time. If I wanted to work out, if I just draw the triangle out again, if I wanted to work out distance, then it's speed times time. So the lines kind of tell me what I need to do. If it's on the same level, I times. If I've got like one on top of the other, then I divide. Now the same kind of thing happens with these triangles here. Now if, let's say, X was here, then what I then need to do is do opposite over the adjacent. If my X was here, then I'm going to times those two things together. If my X was here, then I'm going to divide those two things together. Now this kind of leads in forward, because one thing that you may have spotted in the previous 3 examples is that, if I just go back to those 3 examples, is that my X, well, what I was trying to find was at the bottom, the top of my fraction. So if I go down to question 1 here, you can see that my X is at the top of the fraction. So when it's at the top, we times. And likewise, if we moved on to example 2, again, my X is at the top, and we were multiplying. And like I said, when it came to the 3rd example, again, X was at the top, and we eventually multiplied. Now the question is, what happens when X is at the bottom? Which kind of leads us nicely into our next set of examples. And this is when, so finding a side when X is the denominator of the fraction. Now again, the nice thing about this is that the first steps are exactly the same, and this is why I recommend using these 4 steps, because obviously it will help you. So labeling the sides, and again going from here, so I've got that theta equals 56, h equals x, and a equals 11. So looking at the trig ratios I need to use, so for this case it's going to be cos, so I've got cos theta equals the adjacent over the hypotenuse. Now going through with step 3 and substitute the numbers in, I get cos 56 equals 11 over x. Now if I go back to my triangle of knowing what I need to do, so here I've got my a, here I've got my h, and here I've got cos theta. Now for this, my x is actually at the bottom, and my x is the hypotenuse. So if I was just to casually cover that h, then to work out what x is, I need to divide the adjacent by the cos theta relationship. So what step 4 I need to do is then going to be x equals 11 over cos 56, and I put the 56 in brackets. Now if I type that into my calculator, what I'm going to get is 11 divided by cos 56, which ends up giving me 19.67, and so forth. And to one decimal place, that's going to be 19.7 centimeters. Now again, going back to the original question, x is the hypotenuse, so as x is the hypotenuse, it's going to be bigger, it needs to be the longest side, so therefore I'm expecting an answer that's bigger than 11. And is this number big, is the x value bigger than 11? Yes, it is, so there's a very good chance that I've got this correct. Now another way, if you don't want to use the triangle, of looking at this, now if I just pretend I'm back to this stage again of step 3, so let me just get a different colour pen. So if I take this stage of cos 56 equals 11 over x. Now if I was to take the x over to the other side to get rid of the fraction, then what I've got is I've got x times cos 56 equals 11. Now I want to find the value of x, so I need to get x by itself. So how do I get rid of this cos 56? Well, what is the cos 56 doing? It's multiplying, so the opposite would be to divide. And so if I then, so x is going to equal 11 divided by cos 56, and if I enter that in the calculator, I'm going to get the exact same answer. So it's just another way of looking at it. Now obviously if the triangles help you, go for the triangles. If they don't, then it's fine. As long as you're getting the right answer and you're showing clear working out, then that's all that matters. So let's have a look at the next example. So here again, I'm going through the steps. So step 1, label the triangle. So here I've got theta equals 24, my hypotenuse equals x, and my opposite equals 8. So step 2 then, so the trig ratio I then need to use is going to be sine theta equals O over h. So looking at step 3, so here I've got sine 24 equals 8 over x. Now again, as x is the denominator, then what I need to do is divide those two things together. So again, step 4, and again if you go back to using the triangle, so again we've got O, we've got h, and here we've got sine theta. So my x is the hypotenuse, so then I need to do opposite over sine theta. So then going back to this particular question, x is going to equal 8 over sine 24, and if I type that into my calculator, 8 divided by sine 24, I'm going to get an answer of 19.6687, which coincidentally is the exact same answer as question 1. And it is just a coincidence. So then, moving on again, what I could do is take the x over to the side. So let me just go back and use different colours. So at this stage, I could have x times sine 24 equals 8, and then take the sine over to the side, in which you end up with the same answer. So it's entirely up to you which one you prefer, triangle or the blue method. So then moving on to our last and final example here. So again, going through the notions, step 1, label the triangle. So theta equals 50. My opposite is going to equal 23.5, and my adjacent is x. So I'm going to then choose tan theta equals opposite over adjacent, and substituting the values in, I'm going to get tan 50 equals, and it's going to be 23.5 over x. Now again, x is the denominator, so when I've got x as the denominator, I'm going to divide those two things together. So step 4, and again going back to that triangle, again excuse the presentation of this. So again, my x is the adjacent, so I'm going to do opposite divided by the tan theta, so it's going to be x equals 23.5 divided by tan 50, and if I enter that into my calculator, I get 23.5 divided by tan 50, which gives me an answer of, this is frustrating, 19.7188 and a few numbers, and rather annoyingly we get 19.7 centimeters. Again, so it is just pure coincidence that the three questions have produced the same answers, and apologies for that. In hindsight, probably should have picked different numbers, but who would have guessed? It's just pure coincidence, but hopefully the method is understood. So the key thing, just to summarize what we've learned in this video, is that when we're trying to find the missing side of a triangle, it's all about knowing and recognizing the 4 steps. So 1, label the triangle. Key, massive, important. And remember, don't label anything that hasn't got any information on it. So ignore any blank sides. 2, pick the correct trig ratio. That's, again, really, really important, and there's a very good chance you're going to mess this up if you don't pick the correct ratio. Step 3 is then substitute the numbers in. And then step 4 is then what you then need to decide is, if x is at the top, we times the 2 numbers together. If x is at the bottom, you divide the 2 things together. Remember that the tan theta always goes at the bottom if you are dividing. And then the final step is making sure your rounding skills are good enough. And then when you're trying to find the side, don't forget the units. So try and stick to those 4 labels. Like I said, it's not definite you need to complete step 1, step 2, but I always recommend that you do this, because if you can try and limit for the sake of a couple of seconds and some ink from your pen, it's dramatically going to reduce the errors that you make. And most of the errors that people make with trig is not labeling the triangle or choosing the wrong trig ratio. So hopefully this makes a bit of sense, and like I said, if you have any further questions or would like to have a go at some more practice questions, then feel free to drop me an email at 162maths@gmail.com.